Hello, my name is Mr. Asprey and this is a MADAS Maths applied paper, and this is for the EDEXCEL specification, and this is fantastic revision for paper 3. The paper is longer than regular EDEXCEL papers in order to try and be more exhaustive and get through all the topics. So it's a great way to revise for paper 3. Let's get into it. Question number 1, and we've got a set of data points, and it says find the mean and standard deviation of the data. So I'm going to go to my calculator, I'm going to go to statistics mode, and I'm going to write out all the data points in a list, like this. And then once I've done that, I can press one var for one variable, and it gives me all the information right there. So that tells me that the mean is equal to 241.75, and it tells me the standard deviation, sigma, is equal to 104.64. Next, I've been asked to find the median and the quartiles, so I can go down on my calculator, and right here it tells me the quartiles and the median. So I can write Q1 is equal to 173.5, Q2, the median, is equal to 200, and Q3, the upper quartile, is equal to 315.5. Okay, it says the skewness of the data can be determined by the formula 3 mean minus median all over standard deviation. So I can calculate that by going to my calculator, going to run matrix. I could do 3 over open brackets, then I can press this vars button here to upload some of my data points. So I can press stat, and I can press X, and I need to do the mean, which is X bar, and then minus, and the median you can find by going exit and going to graph, going across and clicking median, close brackets all over, and the standard deviation is back where it says X, so F1, and then there it is, sigma X. Press execute, and I get roughly 1.2. When it says hence this expression, evaluate the expression, and hence state the skewness, so that will be a positive skew because it's a positive number. Okay, draw a suitably labelled box plot for this data. You may assume there are no outliers in this data. Okay, well, I'll just draw a number line across like this. This is going to, the lowest point possible was 110, and the highest point possible was 450. So we'll draw a line here, label that 110, a line here, label that 450, and we've got the quartiles there as well. So this one comes in at 173.5, this one comes in at 200, and then this one comes in at 315.5. Draw a line up like that to connect the boxes, and then connect up the whiskers, and we're done. Question 2, we have a test statistic, and the binomial is distributed X, B, 25, and 0.35. Find the critical region of the test statistic such that the probability of rejecting each tail is close to 2.5%. Okay, we'll go into our distribution function down here at the bottom, and we'll go to binomial, and we want to test both sides. So I'll start with the left side, and we want the number of trials to be 25, and the probability to be 0.35, and I'm going to estimate that it's going to be about 4. Press execute, and that gives me a probability of 3%, which is quite close, so I'll write that down. Probability that X is less than or equal to 4 is equal to 0.032. So that's pretty close to 2.5%, but let's check 3. Let's go lower and let's check 3. So I just press 3, execute, and that gives me 9.6 times 10 to the minus 3, I can check that answer as well just by clicking, not sure actually. Option, edit, there it is. Okay, great, so that is, yep, like I suspected, and the probability that x is less than or equal to 3 is equal to 0.0096. So which is closer? This one is definitely closer to 2.5%. So we'll go with that, and it's a two-tail test, so we're going to have to test the upper tail as well. So I'll press exit, and I will change the distribution. I'll press F4 to go to the upper tail, and I'm going to go with, let's try 12. That's 12%, so let's try 13 to get closer. That's 6%. Okay, that sounds good. Let's try 14. And that is pretty much bang on there, 2.5%. So x is greater than 14 is equal to 0.025, 254. Actually, we have to be a bit careful about truncating here, so let's just press edit. We can look here and you can see it's actually 0.0255. Okay, great. And then just for completeness, I will also try 15, even though I'm pretty sure that it can't possibly be closer than that. Yeah, 15 is 10 to the minus 3 again, but I'll write that down just to show that I have calculated either side. So I'm happy with this. So it does say find the critical region. So I will write critical region is equal to, let's just say x is less than or equal to 4, union x is greater than or equal to 14. Perfect. And part B asks me to find the actual significance level. Now the actual significance level is the probability of rejecting HO incorrectly. So therefore it's what is the chance that I fall within the critical region, and that is 0.032 plus 0.0255, which is 0.0575. Bosh. Question number 3, and we have two variable data, and it says let x and y represent the times run in run 1 and run 2 respectively. Use a statistical calculator to find the product moment correlation coefficient between x and y. So I go into statistics mode and I put all my data in two lists like this, and then I hit F3 for regression, and then I press X, and then I press AX plus B, and it tells me R is 0.6918. So R is equal to 0.6918. Perfect. Explain how the value of the product moment coefficient between x and y will be affected if the individual's times were converted into minutes. That would not change anything. They will still be just as correlated, so it will just be unchanged. Part C, it says test at the 1% significance level whether there is evidence of a positive correlation between x and y. Okay, so I will need to write out my H0 is that rho is equal to 0, and H1 is that rho is a positive correlation is the question. So that means that we have to do rho is greater than 0. And we next will need to find from our tables where the data, how many samples we've got, 1, 2, 3, 4, 5, 6, 7, 8. So we'll have to find n is equal to 8 and sig level is equal to 0.01. And this, from our tables, will give us a critical value equal to 0.7887. Okay, now we compare that to our our value of r, and you can see here that r is less than the critical value. So we write 0.6918 is less than the critical value. So because the value for r is less than the critical value, this means that there is not enough correlation, so we accept H0, and that means that we obviously reject H1. There is not enough evidence to suggest a positive correlation, and we write out that there is not enough evidence to suggest there is a positive correlation. Perfect. Okay, let's move on, and it then asks us to repeat the test at the 5% level. So we still have n is equal to 8. We have 5%, and this therefore gives us a critical value when we check in our statistical tables at the back of our formula book, a value of 0.6215. And then we compare that with our value for r. In this case, our value for r is greater than the critical value, and this means that we reject H0. So therefore we accept H1, and we write that there is enough evidence to suggest a positive correlation. Okay, it says a student was absent from 1-1-1, but he ran run 2 in 80 seconds. Use a linear regression to estimate the student's time in run 2. Okay, well what we can do is we can go to our calculator and we can see what the regression line is. And we have here that y is equal to ax plus b, so we've got 0.595x plus 29.2, and if I need to figure out which is x and which was y, so if I go backwards, my list, the first set of values, that was run 1, obviously put that one in first, and the second one was run 2. And the way that the correlation works is that the first list is x and the second list is y. So therefore we have to use y as run 2. So we say 80 is equal to 0.95x plus 29.2. And we can solve for x by doing 80 minus 29.2 over 0.595. So we get x is equal to 85.4. Question number 4, we've got a histogram. The commuting times of individuals closest to the nearest minute are plotted on the x-axis. That's important, closest to the nearest minute. In the histogram, the class of 47 to 50 has a frequency of 48 and is represented by a rectangle of base 6 and height 3.6. Okay, I'm just going to quickly draw that one. So it has a height of 3.6, and it has a base of 6 centimeters, and it has a class width, and this is where it's nearest to the minute, 47 to 50. So what is the smallest number it could round to 47? That would be 46.5. And what's the largest number which could round to 50? That would be 50.5. So that means that the gap, the class width, is actually 4. And if we know that the frequency is 48, then that is the area of the rectangle. So 4 times 12 must equal 48. Okay, let's now look at the next histogram, and it has a class width of 51 to 55. So if I would just draw this, that means it would start at 50.5 and end at 55.5, and that would mean it would have a gap of 5, and we know, and that's all we know that the area is 30. So I will need to work out the distance in centimetres, and it's going to be proportionate in the same way to this one over here. So x divided by 5 will equal 6 divided by 4 to keep the ratio the same, and that means that x is going to equal 30 over 4, which is 7.5. Okay, great. Oh, and of course, actually, we know the height of this because 5 times 6 must equal 30, but we need to work out the height in centimetres. And again, the proportions are going to be the same because 3.6 centimetres represents a height of 12. So what represents a height of 6? Well, it's just going to be half of that, isn't it? Because 12 divided by 6 is 2. So y is going to equal 1.8. And that's it done. Base of 7.5 centimetres, height of 1.8 centimetres. Question 5, and we have these two events are statistically independent, and that means that the probability of A multiplied by the probability of B will equal the probability of the intersection. So we have 0.4 times by the probability of B will equal 0.12. So therefore the probability of B is 0.3. Probability of the union. The formula for the probability of the union is the probability of A plus the probability of B minus the probability of the intersection. So in this case that is 0.4 plus 0.3 minus 0.12, which is 0.58. Okay, next one I'm going to draw a Venn diagram. I'm going to put A here, I'm going to put B here. So what do we know so far? We know the intersection is 0.12. We know the probability of A is 0.4, so this gap here must be 0.28 to make A 0.4. And we know B is 0.3, so this must be 0.18 to make the B part 0.3. And therefore we know that the outside must be 1 minus the union, so that is 0.42. Okay, so what is this one? The probability of A and not B. So the probability of A and not B is just this area here. That's A and it's not in B. So the answer to that is 0.28. And then we are looking for next the probability of it not being in B, given that it's not in A. So that's conditional probability, which we can write as the probability of B, not B, sorry, and not A, over the probability of not A. So what is the probability of not being in B and not being in A? Well, that's 0.42. And what's the probability of not being in A? Well, A is 0.4, so not in A is 0.6. And this gives me a value of 0.7. Question number 6. A popular bag of confectionery contains 20 sweets, of which a fifth are expected to be orange in flavour. Find the probability that one such bag selected at random will contain at least 3 but no more than 7 orange flavoured sweets. Okay, so this is binomially distributed because it's either orange or it's not. and we're told that there are 20 suites to select from, and the probability is a fifth. And we need to work out the probability that X is at least 3, but no more than 7. So that means that it can be 7, but can't be more than it. And at least 3 means that it can be 3, but it can't be any less than that. Okay, so I can go to I can either go to distribution or statistics mode. I'll go to statistics mode and I'll press distribution, binomial, CD, and I want the lower to be 3, the upper to be 7, and the number of trials was 20 and the probability was 0.2. And this gives us a value of 0.762. Okay, perfect. Next part says a family-sized bag of the same confectionery contains 90 sweets and the proportion is the same. Use a distribution approximation to find the probability that a random sweet will be a randomly selected family bag will contain less than 25 flavoured sweets. Okay, so now the distribution is binomial and it is 90 is the number of trials. Probability stays the same. So in this case we can work out the mu, which is NP, which is 90 multiplied by 0.2, which is 18. And we can also work out the variance as well, which we'll call sigma squared, because that is NP 1 minus P. So that will be 18 multiplied by 1 minus P is 0.8. And this gives me 14.4. Okay, so these are the two things I need to do an approximation using the normal of the binomial. So I can write a new distribution, which is normally distributed, which has a mean of 18 and a variance of 14.4. And remember that sigma, which is actually what we're actually going to use, is going to be the square root of the variance. Okay, now what did the question ask? It said we want less than 25 sweets. So with the old binomial distribution, we would need to do less than 25 is the same as less than or equal to 24. Now using the normal approximation, we need the distribution y to, because y is continuous, we have to think what is the largest number possible which would round to 24 or less. Well, the largest possible number we could use would be 24.5, and that would round to 24 or less. So that is what we have to select using our continuity correction. Okay, so we just go to the normal distribution. So distribution normal, CD, we want the lower, you might as well put a really massive negative number. We want the upper to be 24.5. The standard deviation is the square root of 14.4 and mu is 18. And we get a probability of 0.9566. Bosh. Okay, question 7, we have a biased 6-sided die and the following distribution. This means that you roll it and it's the uppermost face, obviously, and then the die is rolled twice and the independent observations of x, x1 and x2 produce a score of y. So you get a score of 6 if x1 is equal to 6, that's just straight off the bat, game over. And if it's not equal to 6, the first one, then you add the first and the second. Find the probability that you get a 6. Okay, so if we take a pair as x1 observation, comma x2 observation, then which ones will give us our y is equal to 6? Well, we can have just 6 with absolutely anything. X1 is 6, and that gives us it straight away. So just 6 and anything. We could also have 1 and 5. We could have 2 and then followed by 4. 3 followed by another 3. And 4 followed by 2. And we could have a 5 and a 1. So those are all the possibilities. Right, what is the chance of getting a 6 straight off the bat? That's a half. Okay, so that's a half. And then these ones all have the same probability. They all have 1/10 multiplied by another tenth. So we're going to add on 5 lots of 1/10 times 1/10. And this is going to give us 1/2 plus 5 hundredths, which is 55 hundredths, or 11 over 20. Okay, next question. It says find the probability of y being less than 7 given that it is greater than 4. Well, our conditional probability says that we have to do the intersection of these two events divided by what is given. And the intersection of being less than 7 and greater than 4 is the probability of being 5 or 6. And that's over the probability which is given, which is the probability of being greater than 4. Probability of being y greater than 4. Okay, so let's work out first off the probability of being 5 or 6. Well, we know what the chance of being 6 is. And the chance of getting a 5, well, how do we get a 5? The probability of a 5 will be 1 and 4, 2 and 3, 3 and 2, or 4 and 1. So let's just write that again. The probability of getting a 5 will be 1 and 4, 2 and 3, 3 and 2, or 4 and 1. Now again, each of these have the same probability of 1 over 10 times 1 over 10. And there are 4 of them. So this is going to be 4 lots of 1 over 10 squared. Okay, now the probability of getting greater than 4, that would take me quite a while to work out. So I think the quicker way to do would be to do 1 minus the probability of less than or equal to 4. Because that covers all the alternatives. Greater than 4, or the alternatives are less than or equal to 4. The complement, sorry. Okay, so how can I get 4 or less? Let's go back up to our distribution. The probability that we are equal to 4 is we can have 1 and 3, 2 and 2, and 3 and 1. And the probability of getting a 3, that would be 2, 1, and 1, 2. And the probability of getting a 2 would be just 1, 1. So we have 1, 2, 3, 4, 5, 6 different outcomes. And each of them are the same probability, which is a tenth times a tenth, so a hundredth. And there are 6 of them, so that's 6 hundredths. So this simplifies down to 11 over 20 plus 4 over 10 squared, which is just 4 over 100. And that's 1 minus 6 over 100. Okay, so this gives us 59 over 100 on top, over 94 over 100. So this is a probability of 59 over 94. Okay, we have the weight of marmalade jars are normally distributed with a mean of 250. So we write X is normally distributed, mean 250, and some standard deviation squared, which we don't know yet. Calculate to one decimal place the standard deviation of the jars if 1% of the jars are heavier than 256. So that means that the probability that X is heavier, so greater than 256, is equal to 0.01. So I'm going to set up a little sketch like this, and it means we have this area in here is 1%, and we know that value is 256. So we need to find the Z value. So we say that Z is normally distributed with 0, 1, and we go to our calculator and we go to statistics, and we want we want the right side, because you can see the diagram is drawing to the right. 0.01, we want the standard deviation to be 1 and the mean to be 0. And we get 2.326. So the Z value is 2.326. And then we can do our Z swap. So Z minus X minus Z is equal to X minus mu over sigma. So we have 2.326 is the Z value. The X value is 256, mu is 250, and that's over sigma, which we don't know. So we can solve for sigma by doing 256 minus 250 over 2.326. And that gives me sigma is equal to 2.57 or 2.580. Okay, great. Moving up to part B. It says, using your answer to part A, determine the probability that the weight of one such marmalade is between 249 and 253. So you want the probability that is between 249 and 253. So we can go to our calculator and we can go to menu, statistics, distribution, normal, CD, and we want the lower to be 249, the upper to be 253, the standard deviation was 2.580, and the mean was 250. Press equals and we get an answer of 0.528. Great. Let's go on to the next question. Part C, it says, given that the weight of a randomly picked marmalade jar is between 249 and 253, find the probability that the jar weighs more than 250 grams. So this is another conditional probability question. So we do the intersection of these two events divided by what's given. So let's think about how these two can intersect. How can we be between 249 and 253 and also be more than 250? Well, the only way that can happen is if we're between 250 and 253. So the probability I need to work out for part C is I need to be between 250 and 253, all over the probability of being between 249 and 253, because that was what's given. We already know what that probability is on the bottom, so we just need to work out the probability on the top. So we go back, whoops, and we change this to 250 to start, and we get 0.3775, and then we go into run matrix and we put that in, and we get 0.715. Perfect. Okay, question 9, and we have 3 golds in box A, 2 and 2 in B, and 4 and 1 in C, and a box is selected at random and 2 coins are selected from that box, I assume it means. Find the probability that box C was selected if, so that is another way of saying given, both coins were selected. Both coins selected were gold, sorry. Right, so there were 2 events happening here, that C was selected given that both coins were gold. So we need the probability that C was selected intersection 2 golds divided by the probability of what was given, which is that we've had 2 golds. Okay, so I'm going to go ahead and draw a tree diagram. A, B, C, 1/3, 1/3, and 1/3. And then I'm going to just do 2 golds or not, 2 golds or not, 2 golds or not. Okay, so how can we get 2 golds out of box A? Well, we're guaranteed to get 2 golds out of box A because there were no other colours in there, so that's 0, 1. How do I get 2 golds out of box B? Well, the first one would be gold, followed by the next one would also need to be gold. So this is a probability of 2 over 12, which is 1/6. Which means not golds would be 5/6. Not 2 golds, sorry. And here in box C, how do we get 2 golds? Well, the first one would have to be a 4 out of 5 pick, and the next one would be a 3 out of 4 pick. And that would give me 3/5. So 3/5 is the chance there, and obviously 2/5 of not getting 2 golds. Okay, so what do I want? I want the probability of box C and getting 2 golds. Well, how do we do that? Well, the only way to do that is by going down here and then across there. So that is 1/3 multiplied by 3/5. Now what do I want down the bottom? I want 2 golds. Well, that's the orange line, which is 1/3 multiplied by 3/5. Or we can go another way. We can go this way, which is 1/3 times by 1/6. Or we could go another way, which would be 1/3 times by 1, which is just 1/3. Okay, so that's the calculation we have to do. On top we get 1/5. On the bottom we get 1/5 plus 1/18 plus 1/3. And I can put that into my calculator, and that will give me 18 over 53. Bosh. Question 10. Got an iron girder AB has length 8 meters and weight W. A load of 250 newtons is attached to the girder at A. Okay, so let's just start drawing some forces on. So that's 250. We also know that the girder is uniform, so therefore we're going to have the weight of the girder coming down here. And a load of 400 is attached at B. And the girder is suspended by two light vertical cables attached to the girder at points C and D. And we get the distances, and it is in equilibrium, and the tension in the cable at D is 4 times the tension in the cable at C. So let's call this one T, and that will be 4T. The girder is modelled uniform, and the two particles got that. Determine the magnitude of the tension in the girder at C. Okay, well, we've got two unknown forces. We've got T and we've got W, and it asks us to work out T. So we're going to need to take moments at W, essentially. So we're going to take moments at W, and let's have a look then. So this first one, T, this one is a clockwise motion. So that's T multiplied by 3, because that's the distance from W to there. And that's clockwise. And this one is anti-clockwise. So that's 250 times 4. These are the clockwise moments, these are the anti-clockwise moments. And then looking to this side, we've got 4T, 1 meter away, going anti-clockwise. So that's 4T times 1. And then this one over here, that's clockwise, and that's 4 away, so that's 4 times by 400. Okay, so we can equate these now. These are equal to one another because it's in equilibrium. So we get 3T plus 1600 is equal to 4T plus 1000. Okay, 1000. So solving this, we're going to get T on that side and 600 on that side. So T is equal to 600 newtons. Perfect. Determine the weight of W. Well, once we've done this, we just resolve vertically, of course. So vertically, we've got 5 newtons, 5 T's going up, and 5 times 600 is 3000. And going down, we've got 650 plus W. So therefore W is equal to 2350 newtons. Perfect. Okay, question 11. It says, relative to a fixed origin, the unit vectors are east and north as we expect. Particle P of mass 2 is moving under the action of a single constant force F. When t equals 0, the velocity is given as this, the initial velocity, and when t equals 4, the velocity is given as that. Calculate the speed of the particle when t is equal to 0. Okay, well the speed is just the magnitude of the velocity, so we just need to take the magnitude of the velocity vector at t equals 0, which is this one. So that's 3 minus 5. So the magnitude we take by squaring the components, adding them together, then square rooting. So this is 9 plus 25. So this is the square root of 34. Okay, next it says determine the vector f. Now because it's just being pushed by a single force, then it's going to have constant acceleration because f equals ma. So we can use a SUVAT equation here, and we need to find the acceleration to find the force, because again f equals ma. So I write S, U, V, A and T. I'm looking for A, I know t is 4. Well, we know that, yeah, t is 4. The final velocity at 4 is 11.7, and the initial velocity is 3 minus 5. So displacement can do 1, which means we're looking at v is equal to u plus at. So we have 11.7 is equal to 3 minus 5 plus a multiplied by 4, so plus 4a. So solving, this is going to give me 8 on this side and 12 there is equal to 4a. So dividing through by 4, we will get 2, 3. So that will be 2i plus 3j meters per second to the minus 2. And that reminds me, meters per second to the minus 1 up there. Oh, that's not the final answer, of course, because I didn't read the question. It says determine the vector f. So we know that f is equal to mass times by acceleration. And we know that the particle has mass 2, as it says here. So therefore the force is just 2 times by 2i plus 3j, which is equal to 4i plus 6j, and that will be in newtons. Perfect. Find the value of t when the particle is moving in an eastward direction. Okay, so an eastward direction means we're moving this way, and this means that the velocity in the j will equal 0. It's only moving in the I direction, so the velocity in the j is equal to 0. Okay, so we need to set up an equation of motion for the velocity, and we can use this information here to find an equation for v. So we'll say v is equal to ut, so v is equal to the initial, which was 3 minus 5, plus the acceleration, which we worked out was 2, 3, multiplied by t. So I'm interested in the j component. So velocity in the j component is minus 5 plus 3t. And I want to find out when that equals 0. So 3t is equal to 5. So this happens when t is equal to 5 over 3. And that's it. That answers the question because we were looking for the time when that happens. Perfect. Okay, question 12, and we have a pulley system. So let me just draw the pulley like this, and we've got the 2 weights. We have M and we have 4. And we, let's call this one A and this one B. And it says that A moves upwards, which means that M must be less than 4. And we can draw on our forces. So we have mg and we have 4g, and we have tension going up and tension going up. And I also like to draw on the direction of motion. So A moves upwards, so we're going to have it going like this, accelerating that way, and this accelerating that way. And then it says determine the acceleration of the system in terms of m and g. Well, you do an equation of motion and F equals ma for both. So for part A, for mass A, t is going up, so we'll follow the direction of motion, so t is positive, and mg is going against the motion, so that is negative. And that is equal to the mass, m times by acceleration. And for part B, we've got 4g going in the direction of motion, so we'll pull that positive. and tension is going against the acceleration, so that's negative, and that is equal to the mass 4 times by the acceleration. We can then add the two equations, which gives me 4g minus mg is equal to ma plus 4a. And what do we need? We need the acceleration. Okay, so we will take out a factor of a there, and then we will divide through. So we will get g can come out of here, and dividing through by m plus 4 is going to give us a. Perfect. Next, it says show that the tension in the string while A ascends is 8 mg over m plus 4. Okay, so to find the tension, we just sub back into one of our equations. I will sub back into which one to go for. Let's just go for the top one. So T is equal to MA, which is G lots of 4 minus m over m plus 4, and then plus mg as well. So that's just subbing into this top equation here and making T the subject. Okay, so this gives me mg can come out as a factor, and we have 4 minus m over m plus 4 plus 1. And this would be the same as 4 minus m over m plus 4 plus m plus 4 over m plus 4. Okay, so we get m's cancel, 8 on top, m plus 4. So T is equal to 8 mg over m plus 4. As required. Okay, at the instant when A is 1.7 meters from above its original position, okay, it has not yet reached the pulley and is travelling at 1.4 meters per second. Find the value of m. So my first thought is to do a SUVAT for particle A. So let's do that. We have S, U, V, A and T. We're told it travels 0.7 meters up. We're told that it reaches a speed of 1.4. We know that the acceleration is g 4 minus m over m plus 4. And we are looking for of course, sorry, the initial velocity was 0 because it started at rest and then it's released, has this acceleration, gets to this speed, and it covers that amount of distance. So we're trying to find m, so let's get rid of t and let's just use the v squared is equal to u squared plus 2as. We get 1.4 squared is equal to 0 plus 2as. So 2 times by 0.7 is 1.4 times by a, which is g 4 minus m over m plus 4. We can divide both sides by 1.4, which gives you 1.4 is equal to g 4 minus m over m plus 4. And then I can divide through by g, so 1.4 divided by g gives me 1/7. 1/7, so I get 1/7 is equal to 4 minus m over m plus 4. Cross multiply, I get m plus 4 is equal to 28 minus 7m. Add 7m to both sides, take away 4 from both sides, so I get m is equal to 3. Job done. Okay, a particle is projected vertically downwards, so it's not u is equal to 0 because it's been projected. From a great height, it hits the ground with speed 28 meters per second. Determine the time it took for the particle to cover the last 15 minutes of motion. Okay, because the object is falling for the whole time, I'm going to make down the positive direction. And I'm going to do a SUVAT. It'll be accelerating 9.8 meters per second because it's just gravity. We don't know what u is. We know that it's going to hit the ground with 28 meters per second. And we are just interested in the final 15 meters. So let's work out what the time is. So we're going to use S is equal to Vt minus a half At squared. So we're going to get 15 is equal to 28t minus 4.9 t squared. Okay, so this gives me 4.9 t squared minus 28t plus 15 is equal to 0. So I go into my equation solver, polynomial, degree 2, and we want 4.9 minus 28 plus 15. And we get two positive values. So we get t is equal to 5.116, or we get t is equal to 0.598. Okay, now what does this represent? Well, basically you've got this person up here and they are projecting it vertically downwards, and then it's going to hit the floor like that. We've got two answers here. Now, the answer we're looking for is this one, because that's being projected vertically downwards. It's going to get there much quicker. The SUVAT is also telling me that I could get there in this time, and that would be by projecting it vertically upwards like this, and then coming back down. But because that would take longer, that's obviously the purple one, whereas the one we want is the orange one, because it is being projected vertically downwards, thrown straight down. So it's the quickest way to get there. Question 14. A train is travelling at 20 meters per second on a straight horizontal track when the driver sees a red signal 315 meters ahead in front of the train. He applies the brakes immediately and the train deaccelerates uniformly for 15 seconds to a speed of 6 meters per second. The train then maintains this speed for another 12 seconds. The driver then reapplies the brake and the front of the train comes to a stop level with the red signal. Okay. Sketch a speed time graph. Oh no. Oh no. Okay, let's do this. So we've got velocity, or speed, I guess it says. And we have time along the bottom. And we know that it starts at travelling at 20 meters per second. And then straight away it applies its brake, and the train deaccelerates for 15 seconds. So 15 to here, obviously it's going to be going downwards, the speed, because it's deaccelerating, and that takes us to a speed of 6. So maybe not the best graph, maybe a little bit more to scale. And let's go along here and down here, and that will be 6. It then maintains this speed for another 12 seconds, so we go along, and that will take us to 27. And then it reapplies the brakes and it comes to a stop. So brakes, stop. Okay, find the distance travelled by the train from the moment the brakes were first applied to the moment its speed first reached 6 meters per second. So we are looking for this area here, and that is a trapezium which has a height, a parallel side of 20 and 6, and it has a gap between them of 15. So we will do that calculation, and that would give me, I'll do it up here, the area is equal to 2 parallel sides added together divided by 2 times by the gap between them. So that's 13 times 15, which is 195 meters. Okay, great. And now it says calculate the total time from the moment that the brakes were first applied to the moment the train came to rest. Okay, well, we can work out this area in here, because that area is just equal to 12 times 6, which is 72. And that means that we know what this yellow area is, because we know the total distance travelled is 315. So the yellow area is equal to 315 minus 195 minus 72. And that is equal to 315 minus 195 minus 72 is 48. Just so we're clear, that's the yellow area, that was the green area, and that's the blue area. And 48 is a triangle which has height of 6 and base unknown. So obviously base times height divided by 2 is equal to 48. So 96 divided by 6 is 16. So x is 16. So that distance is 16 seconds. Add it to the 27 seconds, gives me a total time of 27 plus the 16, which is 43. Okay, we've got a ladder question. Brilliant. Absolutely gassed for this. Love ladder questions. The diagram is a bit tricky. Not tricky, but it's a bit messy. So I'm just going to draw my own one. Hopefully this will make it a bit more easier to see what was going on. I've got theta in here, and we're going to have a mass mg working down the middle, because it says that it is a uniform ladder, and it's on a rough horizontal ground. Okay, we're going to have reactional force coming up from the ground, and the ladder will be wanting to slip downwards like this, so friction will be working in this direction, and it's up against a smooth vertical wall, which means there is only a normal force coming out of it like that. There's no vertical force from the wall. And it says a child of mass 2m is standing on the ladder at B, which is the point at the end, and the ladder is about to slip. Oh gosh. So that's 2mg. And I think that's it. And it says given the coefficient of friction between the ladder and the ground is that, find the value of theta. Okay, now I'm going to take components. So I'm going to draw a line down here, and then a line across here. This angle in here is theta. And for the child, I'm going to do the same thing here. And then a line across here. And this angle in here is theta. And then I know by kind of Z angles that this angle up here is theta. And I'm going to draw my component of n coming out here and going in here. And I know again by Z angles this angle in here is theta. Okay, so that should be sufficient. Next, I'm going to take moments at, where am I going to take moments? I'm going to take moments at A because I want to cancel out as many forces as possible, and that takes rid of F and R. In doing so, I go up my ladder and I get to my first force perpendicular, which is the green one, and that green force there is going to be the cosine because it's next to theta, so that's going to be mg cosine theta, and we would have travelled a distance of half the ladder, which would be A, so it would be A mg cosine theta. I'm then going to keep going up my ladder and I'm going to get to this one here, and the perpendicular distance is the green one, and that will be adjacent to the angle, so that's again cosine, so that's plus, we've got 2a is the distance, and then we're timesing that by 2mg cosine of theta. And then we also at that point we have a clockwise motion, moment, which is this green line here, which is opposite theta this time, so that's sine. So that's equal to n sine theta times 2a, because the distance. So 2a n sine theta. Okay, we can next do some simplifying. So how many cosine thetas have we got on the left side? We've got amg plus 4mg, so 4amg. So that's a total of 5amg cosine theta, and that's equal to 2a n sine theta. The a's can cancel. And I'm going to need to do some forces now. I'm going to need to do some forces. So let's resolve. Let's look at just the purple forces, and let's resolve vertically first. Again, these moments questions are so similar. You do moments at A, and then you do resolving vertically. So I've got 2mg coming down, mg coming down, and r going up. So that means that r is equal to 3mg. And let's look at horizontal. I've got f going one way and n going the other way, so therefore f must equal n. And let's remember, of course, that F is the frictional force, which is mu r. Mu is 5/12, and r is 3mg. So we get that n is equal to 5/4 mg. Okay, so that can go back over here. So we can have 5mg cosine theta is equal to 2 times 5/4 is 5/2 mg times by sine theta. Mg's will cancel. Divide through by cos theta gives me 5 is equal to 5/2 tan theta. So therefore, dividing through by 5 and then timesing through by 2 gives me 2 is equal to tan theta. So shift tan in degree mode of 2 is equal to 63.4. Perfect. Question 16. and we've got a box which is being pulled at constant speed on a rough horizontal ground by a pulling force of magnitude 70 at 30 to the horizontal. So first off, it's rough, so I'm going to draw a frictional force going backwards, and we also know its weight, so I'm going to draw that going down, and I'm going to draw a reactional force going up, and I'm also going to split this up into components, so that is 70 cos 30, and this coming up is opposite the angle, so that's 70 sine 30. Okay, it says determine the value for mu. Well, let's resolve vertically first in order to work out what R is, because that's helpful to find friction. So I've got R going up, and I've got 70 sine 30 going up. So that must equal the downs, which is 147. Sine 30 is a half, so R is equal to 112. Okay, we know that the horizontals must equal each other, so friction, which is equal to mu R, is equal to 70 cosine 30. So therefore mu is equal to 70 cosine 30 divided by 112. So we will do that. We will do 70 cosine 30 divided by 112, and we will get, I'll leave it as exact value, 5 root 3 over 16. Okay, carrying on, the pulling force is suddenly removed and the box decelerates uniformly, coming to rest after a further 12.25 meters. Find the speed of the box at the instant when the pulling force is removed. Right, classic question this. The pulling force has gone, and what that means is all this has disappeared. So it means we need to recalculate our value for the acceleration, and we've got to recalculate all of our values essentially. So looking at this diagram, is R still 112? Well, I think not. R has changed. R is now 147. So we write R dash, shall we say, is equal to 147. So the new forces going horizontally was just friction. So the sum of the forces is negative friction, which is negative mu doesn't change, but R does. Okay, and this is equal to the mass times by the acceleration. Maybe I didn't explain that as clearly as I possibly could have done. Essentially, the sum of the forces is always equal to mass times acceleration. The forces we've got going on here is a negative force, and it's frictional force, which is mu multiplied by R dash. So this is negative mu multiplied by 147 is equal to the mass, which we know is, we know the weight, which means we know the mass, because the weight is mass times by g, so the mass is the weight divided by g. So 147 over 9.8 multiplied by the new acceleration. Okay, so we can find the new acceleration. That's just calculator skills. And I'm not going to bore you putting that into my calculator. I'm just going to tell you that's minus 5.3044. Okay, great. So now I've got the new acceleration and I know how far it's travelled, or how far it will travel. I need to work out the speed at the start, and I know that it finishes when it comes to rest. Brilliant. That's all the stuff we need for a good old SUVAT. So we have S, we know is 12.25. U is, we don't know, but we know that V is 0 because it comes to a stop. And T is, U is what we're trying to find, so T can do 1. Perfect. So that means we need to use V squared is equal to U squared plus 2AS. So we get 0 is equal to U squared plus 2 times minus 5.3044 times by 12.25. So I will need to do 2 times 5.3044 times 12.25. So all that goes over to this side, become 129.96 is equal to U squared. And then I can just square root my answer, and I get 11.4. Fantastic. Okay, we've got a really tricky projectiles question whereby we have a particle which has been projected like such, with an initial velocity at an angle to the horizontal. We don't know any more details than that, and what we do know is that there's a position here of 4, 2, and there's a position here of 36, 12. Okay, so what we're going to need to do is we're going to need to set up an equation of motion for the horizontal and for the vertical. So for the horizontal, at any given time, we have S, U, V, A, and T. A is 0. U, in this case, is U cosine of beta. And this is for any given time t. So the position, let's call it the x-coordinate, will be equal to ut plus a half at squared. So that's u cosine beta times by t. And then no need for the half at squared because a is 0. And let's look at the horizontal, the vertical. Similar, but acceleration is minus g, or minus 9.8. U is u sine beta. And again, at any particular time. So the position in terms of y, in terms of height, is u t plus a half at squared, like such. Okay, and just like essentially we have a set of parametric equations here, which we can find a Cartesian equation by eliminating the parameter, in this case t. So I'm going to rearrange this one for t, and then I'm going to substitute it into this y1 over here. So warning, this could get messy. X over u cos beta, and then we're going to have minus g over 2. We've got to square this, so So we'll get x squared over u squared cos squared beta. Okay, and then simplifying, we can cancel a u and a here. We have a sine over cos here, which is a tan. So we get y is equal to x tan beta. And then here we're just going to get a gx squared on top over a 2u squared cos squared beta. Okay, now we need to use our two coordinate points. So 4, 2 and 36, 12. So if I sub in 4, 2, that's going to give me 2 is equal to 4 tan beta minus 16 g over 2u squared cos squared beta. And if I sub in my other coordinate, which is 36, 12, this is going to give me 12 is equal to 36 tan beta minus 36 squared is 1296 g all over 2u squared cos squared beta. We can divide this equation by 2. Like so, and then we can also cancel a 2 here, which gives me 4g on top, like such. And over here we could divide through by 12. And dividing through by 12 gives me 108. And then divide that by 2 gives me 54. So 54 on top. Okay. Now I can multiply this one by 9. Sorry, no, that's not going to work. We're going to need to line up these to get rid of these, because these are ugly. So let's make them 108. So let's double this one, and then let's times this one by 27. Okay, so this gives me 27 is equal to 54 tan beta minus 108 g u squared cos squared beta, and this one over here gives me 2 is equal to 6 tan beta minus 108 g over u squared cos squared beta. Brilliant. So now simultaneously we can add these two equations together, or we can subtract one from the other, should I say. And if I do subtract one from the other, I will get 27 minus 2 is 25. 54 tan beta minus 6 tan beta is 48 tan beta. And these two horrible things will cancel out. And that tells me that beta is equal to tan to the minus 1 of 25 over 48. So tan to the minus 1 of 25 over 48 is 27.5. Beautiful. Okay, question 18, and we have a particle of mass 2 kilograms is resting in equilibrium on a smooth horizontal surface. So I can draw 2g going down, and we also would have a reactional force from the surface going up. And what we could do is, if we have two forces acting on the same object, then that is, we can simplify that down to just the resultant force of the two forces. So I've got, and the resultant force we can write as two forces added together. So I'm going to add these two forces one after the other. So we're going to go 8 this way, and then we're going to go 12 this way. And we can now look here by angle rules. If that's 120, this angle in here is 60. Okay, that's going to be helpful. So now we can have this resultant force. We can just deal with this one. And we've also got the reactional force as well. So let's call that one R, and let's call that one F. And notice as well that the light blue F must be going directly upwards. And that's because it's in equilibrium and there's no frictional forces from the surface, which means that the component of the 8 Newton force horizontally must balance the component of the 12 degree force horizontally, which means that we have 0 in the I direction sum force. So F must be straight up like I've drawn here. Okay, what we can do now is we can calculate F, because we've got this triangle whereby we know the angle 60, we know this side is 12, we know this side is 8. So we can use the cosine rule to calculate F. We can do 8 squared plus 12 squared minus 2 times 12 times 8 times cosine of 60. Execute, and then square root the answer. So it gives me root 112 essentially, or 4 root 7. Okay, so that is the force F. And like I said before, it's acting just directly up because the horizontal components must balance because there's no frictional force. Okay, so now we have, we can look at just the blue forces. We have F, and we have plus R is equal to 2G. And we know what F is. So we could do that R is equal to 2G minus 4 root 7. So we get 2 times 9.8 minus 4 root 7. And this gives us a value of 9.01. So R is equal to 9.01 newtons. And now what we can do is we can try and find out this angle. So this angle in here, theta, and it's the same angle here, theta. And because we know that this light blue force goes directly upwards, if we worked out this angle, let's call it alpha, then it would be 90 minus to get theta. So let's use the sine rule to do that. And let's write that sine alpha over 12 is equal to sine 60 over 4 root 7. So we could do that inverse sine of 12 sine 60 over 4 root 7. Gives us 79 for alpha, so I do 90 minus, and that should give me theta of 10.9. So that's that angle, that's the reactional force, and thanks very much. I hope you enjoyed that, and please like, subscribe and share. Bye for now.